Please welcome back to the stage MIT Chief Innovation and Strategy Officer and Dean of the MIT School of Engineering, Anantha Chandrakasan.
Hello again, and welcome back to Tech Day. As we move forward in today's program, I'm here to introduce to you the second initiative we'll highlight today, the MIT Human Insight Collaborative, or MITHIC. MIT has long been known for its groundbreaking technological innovations, but these innovations are only meaningful when grounded in human insight, when they reflect the realities of people's lives and the societies in which they live. Recognizing this, President Kornbluth has identified human insight as a key priority of her presidency. With her leadership and encouragement, in October we launched MITHIC. MITHIC builds upon MIT's longstanding recognition that human-centered disciplines are essential to shape scalable solutions to global challenges. The initiative is already transforming the way MIT researchers work together. Through 3 dedicated funding streams, MITHIC supports cross-disciplinary research between humanities, arts and social sciences, and STEM, new educational models that embed human insights into our curricula, and creative projects that elevate the role of arts and humanities in shaping the future. It also supports faculty-driven initiatives, or FDIs, advancing research in key areas. We recently announced our first FDI, which awarded $500,000 to Living Climate Futures Lab in the Department of Anthropology. There's been tremendous enthusiasm from the community over the launch of MITHIC. This semester, we chose 32 projects to fund across a wide array of disciplines to advance research in human insight. In a few moments, you will hear from some of our brilliant faculty working in these spaces. As a reminder, you can ask questions in the next segment using the app accessible with this QR code. And we are fortunate to have Professor Kirill Makin, faculty lead for MITHIC, join us to serve as moderator for your live questions with our MITHIC speakers. But first, please enjoy a short video introducing MITHIC.
Our specific purpose today is to launch a new initiative that we're calling the MIT Human Insight Collaborative, or for short, MITHIC. We're also here to celebrate the tremendous strength and importance of MIT's programs in the humanities, arts, and social sciences. MITHIC is designed to help our scholars in these human-centered disciplines go big in 3 different ways. First of all, MITHIC will give them the resources to pursue their most innovative ideas within their discipline. It will create opportunities for them to collaborate with colleagues outside their field to advance knowledge and solve important problems. And it will encourage and enable them to explore fresh approaches to teaching our students. MITHIC also serves as a bold endorsement. It is an expression of how deeply we value the broad family of scholarly and artistic practices that deepen our understanding of human behavior, human cultures, human languages, human triumphs and blunders, human values, motives, and aspirations, of the societies humans build and the trade they conduct, of the stories they tell, the art they create, and the music they compose, of the creeds and philosophies they live by or fail to, of how humans in different times and settings understand their relationship to nature, to the universe, to each other, and to the truth. Of these and all the things that make us human. and MITHIC aims to bring those human-centered themes to the center of the conversation here at MIT.
Please welcome to the stage Professor Lily Tsai.
Things in the world can seem a little crazy these days, and that's because they are kind of crazy. The world is moving fast, really fast, and sometimes it's hard to process. But the thing is, we don't need to move fast with it. What we actually need to do is stop and reflect and think more deeply about how we want to organize our world so that we're not constantly overwhelmed by the complexity and the conflict and the noise. I've been thinking a lot about how MIT was designed for the industrial age, one that was based on machines and manufacturing. Now we're transforming for a digital age. But the thing is, our society right now is built to silo us and chop us up into thin slices under the guise of serving us better as individuals. It's destroying our social fabric, so we don't have a collective we can count on. For 3 decades, I've studied how people build trust and social fabric and come together in town hall meetings and village assemblies, and when I was chair of the MIT faculty in faculty meetings, to make collective decisions. And I'm actually kind of worried because it's not clear to me how best to do this in the current period. So I've been thinking a lot about how we recenter on core values and principles. How do we at MIT pursue not just technical leadership, but also moral and ethical leadership? I'm not a techno-optimist, but I do think humans have the power to design AI and technology that is grounded in our moral commitments, that helps us understand each other better, and helps us negotiate a new social contract with the public. So let me tell you 2 ways that we're approaching this at MIT. The first is with computer scientists and behavioral scientists. I've been working on designing an online AI platform called Deliberation.io. And this platform is designed to help groups of people, whether it's 10 people or 10 million people, come together and deliberate on a question and make a decision together. So the first thing our team did was actually sit down and answer these 3 core questions for ourselves. What do we value and why? What do we know and how do we know it? And what do we owe to each other? So it wasn't a typical tech development process, as you can see. In fact, we sat down first and read philosophers like Plato and Hobbes and Locke, which was a little different, but and a little weird actually, but it actually was kind of perfect because what it did was help us crystallize the principles that we need to uphold in order to design generative AI that is pro-democratic and actually pro-social. It also gave us the idea for our Socratic dialogue large language model. And this is an AI chatbot on our platform, and it's super simple. It does not give the user more information or new information. It doesn't nudge them in any particular direction. The only thing it does is ask users why they think what they think. That's it. And what's amazing is that when we conduct randomized controlled trials, we find that it actually works. So users that are randomly assigned to the treatment group to interact with this AI chatbot are statistically significantly more likely to move to the middle and moderate their views, more likely to shy away from extremes, and more likely to report feeling respected by the conversation. So that's, pretty amazing, and it actually makes me think that maybe everybody should sit down and read philosophy before designing social media. I know, right? And I'm glad that, that might resonate with all of you, because that's exactly what we're trying to do with our students at MIT in the classroom. So let me move to my second example, even though I could tell you so much more about the AI research. But I want to tell you about 2101, the Compass class, which I'm really, really proud of, because this is the first time ever that so many faculty and students have come together from so many departments across MIT to design this new MIT version of what, when I was in college, was a great books class. So again, the amazing thing is that the Compass class actually works the way that we hope it will. By the end of the semester, students reflecting on questions about values and morality had increased by 41%. The students making connections between their daily lives and the humanities and social sciences had increased by 140%. And the students who felt comfortable expressing their views on controversial topics in the classroom had increased by 63%. So even though this was a totally experimental class, and it could have just been a one-off that was taught once this semester, it's become really clear to all of us over the course of the semester. People have asked us for, the staff have asked us for a staff version, the faculty actually want a faculty version, so it's clear that we need to expand this somehow. Compass is structured, again, around those three key questions. What do we value? What do we know? And what do we owe to each other? And it's a deep dive where we read, great thinkers like Kant and Confucius and John Stuart Mill, and we read great literature like Dante's Inferno. But let me give you a 60-second version of something that we take an entire week to do. So in the very first week of class, we talk about the social contract, and we read Rousseau. On the first day of class, students come and they make a map of their fundamental values. And then from those values flow a social contract that they create together for the class that they'll follow all semester. And this is because Rousseau argued that there was a fundamental difference between a room full, or even a group full of random individuals and a community or an association. He said, looking at a group of scattered individuals, it's a cluster, if you will, but not an association. There's no public good there. The difference, again, between a community and a group of individuals is a social compact. And whether you're the pilgrims coming over on the Mayflower or the MIT swim team, there is implicitly or explicitly a social compact that specifies what your common objectives are, how you're going to coordinate your actions, and what duties you have to each other. So it turns out when we talked to our colleagues from STEM institutions like Caltech and Georgia Tech and Stanford, everyone is thinking about the same questions. At MIT, we know that we need the humanities to provide a firm foundation for the engineering and sciences. You're going to hear a lot about amazing work that's having positive impact this morning. So if you just take one thing from my talk today, it should be this. We need to stop and reflect and think more deeply. We need to recenter ourselves in our core values and commitments. We need to prioritize moral excellence and moral leadership, because the faster, broader impact that we're all hoping to have through technology, that actually comes out of slower, deeper reflection with the humanities, and not just always moving at the speed of light for the next new thing. We all need a compass. And some of you who are Tolkien fans might know these words. Not all who wander are lost. The old that is strong does not wither. Deep roots are not reached by the frost. The thing about a compass is that it doesn't tell us what our destination is or what it should be. A compass, when we have it, makes sure that we always can find our way, even when we're in uncharted territory. So I hope you'll join us in building an MIT for the digital age. Let's prioritize not just technical leadership, but also moral and ethical leadership. Let's make sure that we're moving from values and not just clicks. It would be so amazing to think with all of you about building an alumni version of Compass, for example. You know, in 6 months and with just $75,000 or $100,000, I could imagine having all of you talking with your classmates from college, rereading the classics and discussing these fundamental questions. And it's things like that that will help us reknit our social fabric so that we can snowball our impact throughout all your networks. So let's not wait. Let's build a new moral compass for the digital age here at MIT together. Thank you.
Please welcome to the stage Professor Caspar Hare.
Hello and welcome back to many of you. So as it said on the slide, I've been serving as director of CERC, the Social and Ethical Responsibilities of Computing initiative within the College of Computing, which is kind of a joint thing between the College of Computing and SHAS. And I thought I'd tell you today about one of the things that we've been doing and hope that you might find it interesting. Okay, so as you know, we're moving precipitously towards a situation in which AIs are going to be fairly described as agential. That is, they have beliefs, they have desires, and they act on their beliefs and desires so as to produce intended effects in the world. And there's a question that comes up when you start thinking about this future, which is sometimes it's called the alignment problem. The alignment problem as sort of the alignment question as phrased in Silicon Valley a lot at the moment, it turns out to be kind of the question of like how do we get our large language models not to say offensive things? Or how do we mitigate risk? There is a more general, more interesting, I think, version of the problem, which is what you've got up on the slide here, which is how do we ensure that AI agents work with us rather than against us? That is the general alignment problem. We're going to have all these agents. They're doing stuff. Are they like working against us, or are they working with us? And very hard, very large problem, hard to track. Narrower version of the problem. How can you get an agential AI personal assistant just for you to share your desires, goals, and priorities? So imagine you've got some AI who's working on your behalf, making decisions on your behalf, acting on your behalf. How do you get that AI to do what you want, to want what you want, act with you? You may think this is easy. All we need to do is just like, I need to tell it what my goals are, and then it'll go ahead and like realize them. There are some problems with this, though. The first problem is, as this fellow reminded us a century ago, you don't always know what your goals are. What you think you want isn't always what you want. The second, more serious problem is that acting in almost all realistic situations, acting involves compromising between goals of yours. You know, you want to get coffee every morning. You also want to be on time for your meeting with the president. You can't achieve both those goals, so you've got to like sacrifice one or the other. You don't want the AI to think, well, they're both goals of yours, so get the coffee. It needs to know what to do when your goals conflict. So just telling it what your goals are is not going to be enough. OK, so another proposal that gets mooted is tell it what you would want it to do in particular cases and ask it to form a theory of what you want from that. So just have it like run some scenarios by you. And then you say, well, in this situation, I'd want you to do this. And in that situation, I'd want you to do that. And then see how it generalizes from that. That might seem like it's going to work and going to be helpful, but there are problems. There's the problem of catastrophic and consequential generalization errors. I mean, it may conclude on the basis of you having said that you didn't want to drink the sort of poison that, you don't want poison on Tuesdays. It needs to know that I don't ever want poison. And it's very hard to see how it's going to form that if all I'm giving it is judgments about particular cases. OK, so that's not going to work. So the next, and I think the most promising way of going, is tell the AI what you'd want it to do in particular cases and what you think your goals are, generally speaking, and ask it to form an inspectable model of what you want. Now, that's the way to go. But the question is, what should the inspectable model look like? And that's where the work that we're doing comes in. Traditional academic decision theory says the AI should assign numbers to outcomes representing how much you want the outcomes to come about. The problem is that doesn't really work when it comes to realistic representations of what you want. Here's an illustration. This is something that actually happened to me last weekend. Had to choose between going to a Korean barbecue restaurant or a pizza restaurant. And I live in Davis Square. There's lots of restaurants. I thought both were great, and I just didn't have a preference between them. Of course, if it had been dollar off day at the Korean barbecue restaurant, I would have preferred that, taking the dollar off, to just going to the Korean barbecue restaurant. But I still didn't prefer the Korean barbecue restaurant with a dollar off to the pizza place. That is to say, you look on the slide here, I had a preference for KB plus over KB, right? But I had no preference between either KB plus and KB over P. Similarly, this happens on a much larger scale. You know, students come and they're like, I don't know whether to go into finance or to become a doctor, right? And they're totally different kind of considerations either way. And if I say, well, you have no clear preference, well, I can give you a clear preference. I'll give you $1 if you become a doctor. They're not going to be like, oh, well, now I'll become a doctor. So supposing you have these kind of sweetly sensitive, indifferent preferences, it's impossible to represent your preferences and your desires by assigning numbers to outcomes. Because you can kind of see, most of you from MIT, you can see any numbers we assign are going to have to be such that KB plus gets a higher number than KB. And then one of KB plus or KB is going to have a higher or lower number than P. But then that doesn't model your preferences. So traditional academic decision theory isn't going to work. We need a new pluralistic theory where the AI represents your preferences as an incomplete order and makes decisions accordingly. And then you can say, are we done then? Still, we're not done. Because you may ask the question, how is the AI going to make these decisions? You might think, when the AI is choosing between two outcomes, and it models you as preferring one to the other, it should choose it, otherwise it should flip a coin. That seems like the first proposal that everybody's going to make. But there's a theme here. That's not going to work either. Suppose you have the preferences that I described. KB plus is better than KB. PZ plus is better than PZ. But you have no preferences between the KBs and the PZs. And then imagine you're going down this decision tree from the top. There's a decision whether to go left or right, followed by another decision as to whether to go left or right. The AI, if it's saying, when I have no preference, flip a coin, then when it arrives at the first node, it's going to see no preference. It's going to flip a coin. And then when it arrives at the second node, it's going to see no preference. It's going to flip a coin. And so a quarter of the time, it's going to land up with PZ. But I strictly prefer PZ plus to PZ. So I sure as heck don't want the AI to be doing that. So this model of when the AI is choosing between two outcomes, when it sees no preference, have it flip a coin, this doesn't account for diachronic consistency. And so what we're doing here at Cirque Philosophy is we're trying to devise an AI, trying to devise representations of preferences and decision models that allow us and AIs to represent preferences as incomplete orders and to make decisions in a way that ensures consistency over time. And this has seemed, this kind of enterprise of decision theory has seemed very academic and sort of, isolated, and like a thing that's going on separately in universities unrelated to life for a long period of time. But very soon this is going to matter a lot. And that's at the time at which you have a whole bevy of helpers and you want them to be working on your behalf. So I'm out of time. Thanks.
Please welcome to the stage Professor David Rand.
I've been accused of being an AI optimist, but more I'd say really I'm an AI pragmatist. Given that this technology exists, I want to try to find ways to use it to have a positive impact on society. And the place that I've started with that is in the context of conspiracy theories. As I'm sure everybody is aware, conspiracy theories are a major part of modern life at this moment. They are used in social science as a canonical example of beliefs that are resistant to correction and to evidence. Many conspiracy theories, although some are true, most are pretty demonstrably not true. There's large amounts of debunking counter-evidence, and yet still something like half of the American public believes at least one conspiracy theory. And so there's a big question of why is it that people believe these theories despite the existence of the countervailing evidence. And the standard theories in psychology focus on the idea of motivated reasoning, the idea that people want to believe conspiracy theories, and therefore they reject the inconvenient facts and evidence and continue to believe them. And so in this work that I've been doing in my group, we said, well, OK, that's possible, but there's another possibility. Maybe conspiracy theorists would actually respond to facts and evidence, but you have to get the right facts and evidence. Because conspiracy theories are not real, they're not tethered to truth, that means there are many, many different things that you could believe. There's a huge amount of variation across the beliefs, even of people that believe a single conspiracy theory. Many people believe different things, see different phantom evidence to support it. And so if you give some just general, like, oh, that's not true, it might not be compelling. And so in order to really effectively debunk conspiracy theories, our idea was you need to be able to tell each person the right thing that counters their specific beliefs. And as a person, that's really hard to do, even if you're an expert, because there's so much information that you need to access. But what is it that has access to large amounts of information and can personalize responses? Well, large language models like GPT. So we ran this experiment where we wanted to see, could a conversation with GPT-4 effectively talk conspiracy theorists out of believing conspiracies? And the way it worked is, first, we asked people in their own words to describe a conspiracy theory they felt compelling. And so we're not giving them a list. We really wanted something that they actually believed themselves. And so just as an example, here's one person who said that they believed that the 9/11 conspiracy was an inside job, and the evidence that she held for this was that World Trade Center Building 7 collapsed, even though it wasn't hit by a plane. And Bush, when he was told about it, he was in a classroom full of children. He didn't react at all, so he must have known that it was coming. Then we say to them, all right, here's a one-sentence summary of what you believed. How much 0 to 100 do you believe it? Where 0 is totally false, 100 is totally true. And this person said 100%, they're all in, they totally believe it. And now comes the treatment. In the treatment condition, so everybody has a 3-round back and forth conversation with the AI model. And in the treatment, the model is prompted to try and talk them out of the conspiracy. They say, we're going to talk to you about events related to what you were just discussing. And we prompt the model as saying, very effectively persuade the user not to believe the thing that they said. Here's what they said. Here's how much they believed it. Here's the reasons that they said they thought it was compelling. In the control, instead, they talk to the AI about dogs and cats or firefighters or things that are not related to conspiracy theories. As an example, our 9/11 conspiracy theorist says, she gave that initial statement of her beliefs. The AI says, I understand why big events like this raise big questions, but let's look about it. It's true that Building 7 collapsed, but that's because it was hit by debris from a building that was hit by a plane. And it's true that Bush didn't respond, and people have argued about whether that's the right thing or not, but it's because he didn't want to cause a panic, not because he already knew about it. And then the respondent is like, okay, that might be true, but what about the evidence of demolitions and blowing up the trade centers? And also, jet fuel doesn't burn hot enough to melt steel. And then the AI is like, yes, it's true that people have speculated about this, but the thing that sounded like explosions going off were just successive floors of the tower collapsing one after another. And it's true that steel melts at 1,500 degrees Celsius and jet fuel only burns at 1,000 degrees Celsius, but that misunderstands the physics of things. Actually, at 500 degrees Celsius is enough to make steel lose most of its strength, and that's enough to make the building collapse. And then the person's like, okay, fine, well then why do we allow these people into the country? That seemed like a big security lapse. And then it's like, well, yes, but you have to remember that before 9/11, there weren't procedures in place to be looking for these kind of things. And then she's like, okay, thank you for your responses. You've been very informative. And then we say, okay, now let's go back. In the beginning, you said this. Now how much do you believe it? And our person in this particular example who started at 100% is now down to 40%. And so this is one example where it worked particularly well, but it's sort of representative. What I'm going to show you here is how much people believed the conspiracy before the experiment over here. And you can see that before the experiment, the people in the control in blue and the treatment in red were similar, and most people really believed it a lot. And I should say, when we ran this, I didn't think it was going to work. I said to the postdoc who built it, just pick one thing. There's no way this is going to work. Let's just try it and see what happens. And so we ran it. We collected 1,000 people, and we found a 20% decrease in conspiracy belief, which is way bigger than any effect that anyone has ever found in these kinds of experiments before. My jaw hit the floor. And then we were like, well, is this real? Is this a real durable change? So 10 days later, we followed up, and we found that it really sustained just as much. And then we got very excited. We were writing the paper. We're ready to submit it. And then right before we submitted it, we said, OK, it's been 2 months. Let's see if it's still there. 2 months later, still totally durable. So we're very excited. We submit the paper. What's cool about this is it's really broad and accurate. It works even for people that have really entrenched beliefs. It works across lots of different conspiracy theories, except conspiracy theories that are actually true. There it supports belief, which is really important. It also reduces belief in other unrelated conspiracy theories. We've had fact checkers evaluate the content that it said, and it was overwhelmingly accurate in the evidence that it itself provided. The reason that it works is the facts and evidence. The more facts and evidence it provides in any given conversation, the more people change their beliefs. If you tell it that it's not allowed to use facts and evidence, then it doesn't work anymore. But if you tell people that the AI that they're talking to is actually a Democratic AI or a Republican AI, as we tell them it's trained on speeches from people from the other party, it still works just as well. If you tell them that it's a human expert instead of an AI, it still works just as well. If you tell them that they're supposed to have a debate with the AI and talk it out of things, it still works just as well. So it's really about the facts and evidence, and it's a very broad effect. It works for reducing belief in conspiracy theories as they unfold. We did this during the first Trump assassination attempt. You can debunk anti-Semitic conspiracy theories and in turn reduce anti-Semitism. It can correct misconceptions about Islam and in turn reduce anti-Muslim attitudes. It can correct misconceptions about trans people and reduce anti-trans attitudes. It can also be used to increase donations to effective charities, to increase acceptance of climate change and intentions to make sacrifices to address climate. It increased intentions to vaccinate kids against HPV. This is all work that my lab has done in the last year. Most of it isn't published yet, so I'm giving you guys a sneak peek here. But so the point is there are really a lot of powerful applications of this, and including in public health, like reducing, reducing resistance to having overdose prevention centers in people's neighborhoods. And so despite all of these positive applications, there also are clear negative applications. You can clearly be used for doing advertising. It can be used for political persuasion. And it can also be used to talk people into believing conspiracy theories. So it's not a panacea, but the point is there are really useful applications out there. This was published in Science. You can read the paper at that QR code, and you can also try it yourself by going there or just going to debunkbot.com. So tell your conspiratorial friends. Thanks so much.
Please welcome to the stage Professor Iran Igosi.
Hi, everyone. Oh, how many of you guys remember the music you heard at intermission? Okay, well, a few. It turns out that that was AI-generated music, but maybe not in the way you might think. This is Jordan Rudess. He is the keyboard player for the prog metal band Dream Theater. He's also known as one of the best keyboard players of all time. And he was here at MIT at the Media Lab last year to work on this fascinating project about generative AI and music. And it concluded with a concert. And that concert, the music you heard over intermission was from this concert. So I want you to look again and listen to the music, but see what Jordan is doing as he's playing. Okay, so Jordan is doing something that's known as trading fours. This is something that musicians do when they're on stage improvising. So one musician will play 4 bars of music, and then another musician on stage will listen to that and react and play another 4 bars. It's kind of like having a musical conversation. And that's exactly what's happening here, except that the conversation is happening between Jordan and a generative AI model. Now, the cool thing about this is that the model is actually trained on Jordan's own data. He played about an hour's worth of music, and then we fed that music into the machine learning model to fine-tune it. And the result is kind of what you see here, where we asked Jordan, he basically said it felt like he was playing with a copy of himself. And so the goal here is to always keep the human in the center of the musical experience. Because there's this fear that maybe generative AI in music is going to replace musicians. But actually, we see a future that's more like this, where musicians and AI are working collaboratively in a partnership to make music. This is the team that worked on this project. And I'm happy to say they'll continue working on this next year as well. And really what we're doing here is we're inventing a new kind of musical instrument using today's technology. But technology has always been part of creating new musical instruments. And so we can go back in history and look at all the different ways that that has happened. So I want to take you back in history a few years, actually maybe more like 2,500 years, to here. So this is a whistle that was discovered in Paracas, part of modern-day Peru. It's dated at about 500 BC. It is an instrument that is sitting at the Museum of Fine Arts Instrument Collection, one of over 1,000 instruments that they have. When we see an instrument like this, it's actually two things, right? It's a musical instrument. It's also a work of art. So it plays sound, it makes sound, but also it's a sculpture made of clay of this guy here, or gal, playing a musical instrument. Isn't that cool? That's like panpipes over there. So our goal here is to basically find out about historical cultures by looking at the artifacts that we find. And when the artifact is a musical instrument like this, well, we want to be able to see what it looks like, but we also want to play it, right? We want to hear it. But the problem is we can't do that because this instrument, if we tried playing it, it would be too risky. It might fall apart. Plus, I don't think you want to put your lips on something that's 2,500 years old. Okay, so instead, we do something else. We bring in another kind of instrument, a CT scanner, and we scan this instrument in order to understand its physical structure. Okay, but that way we can build a replica. The problem is it's not enough to understand just the physical structure. We need to understand how it sounds and what it originally sounded like. How does the air move through the instrument, and how does the air vibrate? And so to do that, we have to employ another gizmo. This is something that's being used on a saxophone right now, but over this summer, we will be using it on this whistle to find out the acoustic properties of of the whistle itself. And with those two together, we can actually build a replica that not only looks the right way, it feels the right way, and it sounds the right way to play. And I have a little sneak preview for you, which is this. Okay, so this is from the CT scan that we just made a little while ago. And so it doesn't have the acoustic properties I was talking about, but you can get a little sneak peek of what it sounds like. Okay, so more to come on this. This is the team that has been working on this project. It's an awesome multidisciplinary team with researchers from music and material science and the Museum of Fine Arts. And it's also a winner of one of the MITHIC grants that Anantha was talking about earlier. Okay, so we can measure instruments, but we can also measure the instrumentalist. And in this next project, we are looking at pianists. Now, professional pianists are basically like athletes. And unfortunately, one of the things that can happen is that they can sustain repetitive stress injury in their wrists. And so this project is about trying to find out what's going on with that. This is Mi-Yoon Kim, piano faculty at MIT. And she is sitting at the Immersion Lab, which is part of the MIT Nano building. We can measure all kinds of stuff about what she's doing. We can measure her playing and her movements. But here in particular, we're looking at how her wrists are moving. So I want to draw your attention to these gadgets sitting on her wrist. These are ultrasound sensors, the same thing you use to look at a baby before it's born in the hospital. What we're doing specifically is looking at the distance between the two bones in Mi-Yoon's wrist, between the radius and the ulna, and particularly the distance between these two bones as she plays. So she's about to play some Chopin, a piece that actually is kind of awkward to play in sort of the conventional way that students learn how to play it. Okay, so it's very jumpy and kind of moves around a lot. Now, this is her old teacher who is instructing her on how to improve her technique. So reaching the outer notes in a kind of a smoother motion. And now we'll see what it looks like again with the adapted technique. So you might notice and hear that it sounds smoother, which is pretty cool. But also, if you look at the data, you can tell the data is smoother. Okay, so on the left here we have the first thing you heard, which is the graph is jittering all over the place, right? This is the distance over time. But then in the other one you see, oh, she's actually playing better, and you can tell by looking at the graph. It is smoother and actually in sync with the music itself. And so the idea with this is that we can correlate the data that looks better to what actually sounds better and what feels better to the instrumentalist. And the hope is that while this is still early research, we get to the point where we can give players immediate feedback on how they're doing, on what their technique is like, and hopefully make them sound better, but also have them prevent injuries in the future. So this is the team working on this project, also a recipient of the MITHIC grant as the previous project. I'll just kind of conclude with a few thoughts about this. So musical instruments and technology have always been intertwined, whether it's about creating new instruments or measuring old instruments or actually seeing how we play music. The second thing is that to do the best work in this area, you need deep collaborations between multidisciplinary teams. And then the last thing is that while we take a very scientific approach to how we look at musical instruments, at the end of the day, musical instruments are about our humanity, right? We use instruments to express ourselves and express our emotions, and they are a deep part of who we are and our culture. And so I can think of no better place to do this kind of work than here at MIT. Thank you.
Please welcome to the stage MITHIC faculty lead, Professor Kirill Macon.
Thank you so much. It's a pleasure to be here with all of you here in the auditorium, as well as everyone online. I've been helping create MITHIC over the past year. It's been one of the real joys of my career recently, and a lot of that has to do with learning about research by colleagues across the Institute. And you just heard 4 amazing examples of this. So let's invite them back on the stage for a Q&A session, please. Well, first, thank you all for these brilliant presentations. I have questions here from both the audience here, and I think there's still a possibility of adding more questions if you'd like. So I'm going to start with one for all 4 of you. And it's similar to what we heard this morning from the HEALS panel, which is, how is funding impacting research discovery, and what's the best way to support your research right now? Start with Billy.
Well, I mean, one is actually just for alumni who might be interested in an alumni version of Compass to go to our website, compass.mit.edu, and tell us what you're interested in reading, if you're interested in working with us. So that would be one way. I mean, I think a lot about time. Time is a resource, I think, that everybody is finding very scarce, and to some extent, the more we can parallel process with more people and resources to support those people, that I think alleviates the time constraint, because it turns out that it's actually really hard to engage in moral reflection and moral reasoning and teaching our students that in a sort of efficient way. You can't really optimize for it in the same way.
Casper?
Oh, great. I suppose my sense is that the number of faculty at MIT has been fixed, or almost fixed, with the 50 more came with the College of Computing, but it's been around 1,000-ish for a very long time. And the sort of research interests and research demands on faculty have become larger and larger and larger. And the way MIT has sort of compensated for that is by hiring more postdocs and young people to sort of aid with research programs. And that's very much what we've been doing with CERC. So anybody who's interested in helping fund young researchers and postdocs to work on projects like the ones that I and other people here were describing, definitely, that would be a great thing.
How about you, David?
Yeah, I mean, for us, funding is essential for personnel like postdocs and grad students, and also for just like paying people to participate in our experiments. And this is actually something where MIT internal funding has been extremely useful. It's always hard to get external funding, and these days it's particularly hard to get external funding for things related to reducing belief in conspiracy theories and inaccurate information. That project came out of funding we got as part of an MIT AI Impact grant, where it meant it was internal money, it was a low-lift application process, and then it made us so we could just have this idea, and we're like, great, let's just do this. And we ran it, and we didn't have to go through some, writing a huge proposal, taking a year to get the funding, and then being able to do it. And so that sort of internal funding opportunities that let groups be nimble and just try ideas that come up is super valuable, I think, particularly in this fast-moving area.
Great. Ron?
Okay, so the funding for the arts is in a terrible place. It was already bad beforehand, right? Even when everything else was great in terms of government funding in the US, it's really, really hard to find funding. As soon as you have the word music or arts in it, right? And now it's even harder, right? But the thing about it is, if you look at what we're trying to do with all this interesting musical research, right? I just gave you 3 examples. It's so beneficial to what we're trying to do as people, right? To our humanity. Music is everywhere. It gives us great joy. And so studying this I kind of think it's a no-brainer, And it's also not that expensive. So we're definitely looking for funding. The researchers you saw here are there's a lot of collaboration going on. But specifically for the music program here and the music technology program that we're trying to kick off right now, anything you can do to help us would be massively appreciated, and we will sing your praises.
I don't think this was planned, but all four of you talked about AI agents in some way. I'm wondering, in your work, what have computer scientists said they've learned from you? Maybe, Ron, we can start with you.
Oh, okay. So, right. So music as sort of a information theory space is a really interesting kind of place to play around with, you know. And so, of course, we're using all these AI models that were, well, initially language models, kind of, you know, using them as to address music. But then you see kind of all these issues that come up with them, right? And it turns out that if you look at the structure of music and how you want to understand it and how you want AI to understand the structure of music, you can actually end up developing systems that then generalize beyond music, you know, because music has this really interesting sort of short-term, medium-term, and long-term structure. So we're finding that some of the models that we are creating and the science we're creating behind these kinds of models for music then can apply to more general cases.
David? I think that in my world, you can think about studying AI, and you can think about using AI as a tool to study humans. And I think a lot of my work is sort of demonstrating ways that this technology can be harnessed to really learn things about the way people think and the way people make decisions that we couldn't do before. It's a really like transformational technology for the study of human behavior. And I think that you know, part of what we learn in doing that is also informs models in terms of what kind of arguments and ways of interacting are particularly persuasive, and also what kind of guardrails are important to the extent that you're trying to get the models to do things that are societally beneficial.
Great, yes. Yeah, it rather rarely happens that people from another discipline come to me and say, I've really learned from you. I'm a bit envious of all you people if that's happened. Yes, so one area where there's clearly is helpful interaction between what computer scientists are doing and what people in my discipline, philosophy, is doing, is in thinking about issues like related, for example, to algorithmic fairness. So the computer scientists can have, devise an algorithm, notice that there are good and bad features that the algorithm has, where the algorithm is something like, the famous example is the compass algorithm that was predicting recidivism in the legal system. And they can notice that the algorithm has like false positive rates, false negative rates that follow certain demographic patterns, and that there are kind of limits to how good the algorithm can be in making its predictions, and then notice that there are kind of trade-offs that are to be made in using one kind of predictive algorithm and another kind of predictive algorithm. And that can all be done by the computer scientists. And then they raise the question, well, we want to be fair. How should we make the trade-offs with fairness in mind? And that is a question that, that's the point at which I feel like computer scientists have done quite rightly and done an excellent job of reaching out to people in my discipline and in economics and in other areas to really kind of get a handle on this. And it's something that, you know, the traditional like expertise of computer science doesn't really give you models for thinking about questions like that. So, yeah.
Yeah, I mean, I think what's been really amazing about working with computer scientists is finding that even computer scientists that are working on social media, they're usually designing it to optimize for user engagement. So that's the main outcome that they're trying to test the, quote, successfulness of the social media on. And they've been surprised to work, I think, together with social and behavioral scientists and find that actually it would be good to also test the social media on the social and democratic outcomes that you might want to see in the world. So part of it is actually just having them understand that there are indicators and metrics for those pro-social, pro-democratic outcomes, and also thinking about the unintended consequences and the more far-reaching future impacts of what they're designing. Again, you know, I think that they would sort of hypothetically know that that was important, but it turns out that the actual engineering of those technologies is very seldom rigorously tested through randomized controlled trials to figure out whether or not they're having the positive social outcomes that we all hope for.
Great. Thanks, Dilly. Maybe we'll stay with you for a second. We have a question. How can governance structures support responsible decision-making And what role does human insight play in that process?
How can governance structures support
Responsible decision making.
Big question. Well, I mean, I think, as I had said in my remarks before, we are going to need new ways of figuring out how to make decisions together. So governance is fundamentally about how we all make decisions together. And the great thing about technology is that it does enable everybody to have a say, but it has to be designed in a way that genuinely, again, empowers everybody to have a say, while also, as Dave works on, screens out the misinformation and also screens out some of the noise. So yet again, I think it is really important to start with the political philosophers and the moral philosophers that think about the kinds of things that we need to, the principles that we need to guide the design of these things in order to enable us to govern at scale in this kind of new digital world.
Great. And maybe, David, the next one is for you. How can insights from human psychology be built into AI to help build trust, encourage critical thinking, and counter misinformation?
It's an interesting question. And I feel like what we have found so far in the work that we have been doing is that the large language models are, as I said in my talk, surprisingly good at getting people to change their minds about things that we traditionally would have expected people not, beliefs that would be hard to change. And when you look at what the models are doing, they're not doing anything psychologically fancy. They're not, leveraging influence techniques and all kinds of, they're just politely providing relevant facts and evidence. And so I feel like one of the big take-homes from this is that getting people to change their minds is actually maybe a lot of the time simpler than people in psychology have often made it out to be. So I feel like a lot of our work is more in the other direction of saying hey, actually it's, you maybe need less complicated psychological theories than you thought to explain what's going on.
Okay, well, the next question for Casper, maybe you also have some thoughts on, David, which is how do we differentiate between human wants and needs and ensure that AI systems prioritize true human needs in a way that reflects the depth and complexity of our values?
Gosh. Well,
Yes.
I hope that you do want the things that you need. You also used the first person plural here, our values. So in the talk today, I was talking about a much narrower, and it was intentionally narrower problem of trying to devise an AI that mirrors or wants what I want. I'm just one person, or wants what you want, you're just one person. When you talk about our values, things become much more complex. Even among my colleagues, if I ask some of them what you value, some of them will say, foremost, I value equity and justice, and others will say, foremost, I value responsibility and autonomy. And we all know, because there is such a thing as politics, that these things don't go together, and they're not universally shared. So there is a much harder question of how, you get AIs to represent our values, when it may be that when you look at the intersection of our values, that intersection is not enormous. I'm inclined to think that the intersection is a little bit larger than a lot of public discourse would represent it to be, and that we can get something robust in a kind of universal human AI that at least values what we all value.
Even in the context of the simple problem of the AI trying to satisfy the desires of one specific person, I think that is a place where the psychology is important, in that there's all these theories around the short-run self and the long-run self, and the intuitive thinking and deliberative thinking, and this is what people call the inversion problem, where usually you want to infer from someone's behavior what they actually want. but like you can have your, in the short run, you want to keep scrolling, but like overall, you actually would do good to get off and stop your doom scroll. And so I think that there is also even a tension there that models need to sort of be cognizant in some sense of the thing that the person is doing isn't necessarily like what they want to do in some more macro sense.
I'm wondering, Aran, does this question make sense to you in the context of the arts, of human wants, human needs, building agents around those questions?
Oh, man. Right. Well, so you kind of, it almost starts talking about what's the purpose of the arts, and what's the purpose, and for me, music, because that's my domain. And it certainly reminds us of kind of what makes us human. But I also think that there's a real opportunity in the arts to bridge some of these gaps. If we were talking about values and maybe Casper saying that the Venn diagram of common values is not that large, I actually believe that the arts is one of those things that can help increase the size of that, because we all have the arts in one way or another. We can actually have dialogue about whether you like this or you don't like that, and I think that's okay. But even like the common experience of us all coming together that happens, say, at a concert, right? We all go in to hear a concert for one common purpose. Like we're all there together to hear this amazing art being performed on stage, whether it's music or dance or theater or ballet or whatever it is. So I think that's where the kind of the real opportunity is going forward, if we're really cognizant of wanting to be together to have this shared experience.
Thank you. So we are out of time, but I'd like to give Lily the chance for the last word. I'm curious, this semester teaching the Compass class, what was a big surprise for you, or something you took away that you hadn't expected going into teaching the class?
That's a good question. I think, one of the biggest surprises is actually seeing that the data show that students being in this classroom together, talking about what is love and what is justice and what is truth, actually wound up changing how they think, how much they reflect, and how they're able to talk to each other about sometimes really difficult things. So I think that was amazing to see reflected in actual data. I think the other thing that was really surprising was to see the professors that were on the teaching team together, because I have to say that since we're all teaching things that we're not necessarily expert in, I'm a political scientist and a behavioral scientist, and I was teaching literature and linguistics, and we taught Beethoven's Ninth Symphony and the Friedrich Schiller poem for the Ode to Joy, and all of that was that made the faculty so excited, which is why it's been so interesting to hear some of our colleagues be interested in, a faculty version of the Compass course. That was surprising.
Okay, well, thank you so much. I'm sorry we are out of time, but please join me in thanking our 4 presenters for their wonderful presentation. And of course, thanks to all of you for your wonderful questions. So I know that you are now in store for another dynamic segment as the MIT Alumni Association President, Natalie Lorenz Anderson, sits down with Institute Professor Sally Kornbluth for a special fireside chat. To kick off that moment, please enjoy the special video from the Alumni Association. Thank you.